Hi guys, welcome to our first recap video. We are going to be recapping what we did from October 18th to October 22nd, and this was dealing with systems of equations. This week we solved systems of equations using both substitution and elimination, and then we'll tackle the word problems as well. So let's get started. This first example is solving a system of equations by substitution. Remember, when we have a substitution problem, we're always looking for the variable that's by itself. And in this case, I have x by itself. So I'm finding x in my other equation. There it is. And what we're going to do is I'm going to box what x is equal to, and I'm plugging it into the other highlighted piece. Okay, make sure you're drawing that box, drawing that arrow. Otherwise, sometimes we get confused about how we're plugging in. So my original equation was 2x plus 3y is equal to 12. And I had highlighted my x, and we said that our next step would be to replace the x with whatever it's equal to. Okay, but let me just finish writing this first. That's always good practice. Otherwise, sometimes we forget what we're writing. So x was equal to 1/2 y minus 6. That goes in this green highlighted part. Once we have that, make sure you have your calculator out, and we are going to distribute this 2 outside our parentheses. So 2 times 1/2 y is just 1y. 2 times negative 6 is negative 12. We have a 3y, so let's bring everything else down. And we have to bring down our equals to 12. After this, we combine like terms. 1y and 3y combines to give us 4y. Bring down our negative 12 equals to positive 12. Now it's just a two-step equation. First, we're going to move that minus 12 to the other side by adding 12 to both sides. I get 4y is equal to 24. And then we're going to divide by 4 on both sides to get y by itself. Y is equal to 6. Remember, in a system of equations, we are not done, right? We have to go ahead and plug back in to solve for our other variable. In this case, that's x. When you're looking at your two equations, choose the one that's easier for you to solve for x. For me, it's going to be the second equation because x is already by itself. So it's x equals to 1/2 y minus 6. I know what y is. Y is equal to 6. Let's plug that in. Put this into your calculator. 1/2 of 6 is 3. So that's 3 minus 6. 3 minus 6 is negative 3. Remember, our final answer we should write as a coordinate pair. The x value comes first, so that's negative 3, and our y value is 6. That was one example of a system of equations by substitution. Look at this next example. Go ahead and pause the video here if you want to try it by yourself first, and then we can go over it. All right. First step is to highlight the variable that's by itself, and I have it here. I have y equals, and then I'm going to highlight the y in our other equation. Now I'm going to box what the y is equal to and draw my arrow so I know where I'm plugging it in. And you don't have to do this, but I always like to rewrite my equation. 4x plus 3y is equal to 27. Again, the y was highlighted. So that's 4x plus 3, and then I'm replacing that highlighted y with just my own highlight. Equals to 27. For the y, we are replacing it with what I've boxed. This is 2x minus 1. Once we do that, next step is to distribute. Well, we're going to bring down the 4x because I'm not distributing that. Distribute the 3 to the 2x. 3 times 2x is 6x. 3 times negative 1 is minus 3. That's equal to 27. Now we're going to combine like terms. 4x and 6x is 10x. Bring down your minus 3. Bring down your equals to 27. Two-step equation. First thing we're going to do is move that minus 3 to the other side by adding 3 to both sides. I get 10x is equal to 30. And now let's divide by 10 on both sides. X is equal to 3. Again, we have to make sure we are also solving for y. For me, the easier equation is the second equation, which says y equals to 2x minus 1. Let's plug in. Y equals to 2 times 3 minus 1. 2 times 3 is 6, so that's 6 minus 1. Y is equal to 5. All right, and again, let's write our final answer as a coordinate pair. X value comes first, that's 3, followed by our y value, which is 5. This was system of equations by substitution. Next, we'll talk about solving a system of equations by elimination. Remember, to solve a system of equations by elimination, we need opposite coefficients. If you take a look at your coefficients right now, I have a 3 and a 4. Those are not opposites. And I have a 2 and a 3. Those are not opposites, right? So we talked about how to do this. And what we need to do is we need to multiply both equations. This part, really, really simple. To figure out what you're multiplying by, just look at what we have in the other equation. On my top equation, I have a 3x, so I'm going to multiply the second equation by 3. On my second equation, I have 4x, so I'm going to multiply the top equation by 4. Make sure when you are multiplying, I did suggest to you guys, draw the arrows. Otherwise, sometimes we end up messing up. So 4 times 3x gives us 12x. 4 times 2y gives us positive 8y. And then 4 times 4 gives us 16. Do the same thing for the bottom equation. 3 times 4x is 12x. 3 times 3y is positive 9y. And 3 times positive 7 is positive 21. So we're almost there, right? Because I can see that I have 12 and 12, but they're still not opposites. To get them to be opposites, we're going to change one of the equations, and I always choose the second one, by changing all the signs. So 1 second, let's recopy the first equation over. And for the second equation, you're going to change the sign of every single term. So the positive 12x now becomes a negative 12x. The positive 9y becomes a negative 9y. And the positive 21 becomes a negative 21. Once you have this, we can solve by elimination because I now have what I want. Positive 12 and negative 12, right? So that means that this can be eliminated. My x's can be eliminated. Now add these together. Positive 8y and negative 9y gives us negative 1y equals 16 plus negative 21 is negative 5. Divide by negative 1 on both sides. I get y is equal to positive 5. Again, we are not finished because we need to solve for x. I always choose one of the original equations. Doesn't matter which one, I'm going to choose the first one. 3x plus 2y is equal to 4. I know y is equal to 5, so let's plug that in. 3x plus 2 times 5 is equal to 4. 3x plus 10 is equal to 4. Minus 10 from both sides. I get 3x is equal to negative 6. And then divide by 3 on both sides. We get x is equal to negative 2. Again, our final answer as a coordinate pair. So that's negative 2, comma 5. Remember, the x value always comes first. All right, guys, down here, I have an example you guys can try to do using elimination for the system. So you guys can pause the video here and then go ahead and play it when you're ready to go over it. All right, let's start. So again, we're looking for opposite coefficients, but I don't see opposite coefficients, so we are going to need to multiply. We are going to be multiplying the top equation by 7 and the bottom equation by 6. When you multiply, please make sure you draw the arrow. 7 times 6x is 42x. 7 times 5y is 35y. And then 7 times 9 is 63. And do the same thing for the bottom equation. 6 times 7x is 42x. 6 times 2y is positive 12y. And 6 times negative 24, let me put that into my calculator, is negative 144. Okay, notice I still do not have opposite coefficients, right? I have 42x and I have 42x. They are not opposites. If I want them to be opposites, we need to change one of the equations, and I'm going to change my second one. Take your second equation and flip every single sign. So 42x becomes negative 42x. Positive 12y becomes negative 12y, and negative 144 becomes a positive 144. Now that I have opposite coefficients, we can eliminate. The x's will eliminate because I have positive 42 and negative 42. Now, next step, let's add these together. 35 plus negative 12 gives us 23. So I have 23y, and now let's add 63 plus 144. That gives us 207. To get y by itself, divide by 23 on both sides. 207 divided by 23. 207 divided by 23 is 9. So I get y is equal to 9. We are not done. Remember, we need to plug in order to solve for the other variable. Choose any equation. I'm going to choose the first one. 6x plus 5y is equal to 9. I know y is equal to 9, so let's plug in. 6x plus 5 times 9 is equal to 9. That's going to be 5 times 9 is 45. So 6x plus 45 is equal to 9. Minus 45 from both sides. I get 6x is equal to negative 36. Divide by 6 on both sides to get x by itself. X is equal to negative 6. Again, let's write our answer as a coordinate point. X value comes first, which was negative 6, followed by our y value, which is 9. This was solving a system of equations by elimination. And last but not least, this week we also did solving a system of equations using, word problems. So let's go ahead and look at that. First one, not first one, it's all one problem. For a class picnic, 2 teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. Write a system of equations to represent the cost of juice box J and a bottle of water. So J is the cost of my juice box. And W is the cost of water. When we are writing our equations, we are just going to match up our variables with how much they bought. So one teacher bought 18 juice boxes. So that's 18J and 32 bottles of water. If you're buying them together, you're going to add them together to find out how much we spent. That's equal to $19.92. The other teacher purchased 14 juice boxes, so that's 14J, and 26 bottles of water, so plus 26W equals to $15.76. That's it. We wrote our system. That's all we need. All right. Part 2 of this problem says Kara said that the juice boxes might have cost 52 cents each and that the bottles of water might have cost 33 cents each. So this is what Kara is saying. Kara says juice box is 52 cents and that water is 33 cents. The problem says use your system of equations to justify that Kara's prices are not possible. So I'm going to take my equations. Let me take this red one first. And I'm going to plug in Kara's numbers. So 18 for juice box, she said that's 52 cents. And then plus 32 for water, she said that that's 33 cents. And let's see, that's supposed to equal to $19.92. So 18 times 0.52, we end up getting, this is 9.36 plus 32 times 0.33. I end up getting, this is $10.56. Is that equal to $19.92? Let's add them together. If I add them together, 9.36 plus 10.56, I do get 19.92 is equal to 19.92. So Kara's values work for the first equation, right? But now we need to take it and make sure it works for the other one. A system of equations has two equations, so we need to make sure it works for both. So again, I'm going to plug in numbers. For J, she said juice was 52 cents, so I'm plugging that in. Plus 26. For water, she said that was 33 cents, and that's equal to $15.76. Let's multiply 14 times 0.52. I end up getting, this is $7.28 plus 26 times 0.33. This is $8.58. Is that equal to $15.76? Let's see. If I add these two together, I end up getting $15.86 is equal to $15.76. That does not work out. That's all we needed to do to show that Kara was incorrect, right? $15.86 is not equal to $15.76. All right, part 3 says solve your system of equations to determine the actual cost. So I'm going to bring my system of equations down, and we are going to solve this. We just finished doing system of equations by elimination. I think you guys can do this. We're going to multiply the top equation by 14, and then I'm going to multiply the bottom equation by 18. When you multiply, please make sure you draw your arrows. So 14 times 18, I get 252J. 14 times 32, I get 448W. And then 14 times 19.92, that's going to be equal to 278.88. Do the same thing for your bottom equation. 18 times 14 is 252J. 18 times 26 is 468W. And then 18 times $15.76 is going to be $283.68. Again, we still don't have opposite coefficients. I need to change one of them to change the signs of every single piece. So I'm going to recopy the first equation over, just down here because I don't have room. 252J plus 448W is equal to 278.88. And then all I'm going to do is change the sign of every single term in the second equation. 252J, make it negative. Positive 468W, make that negative. And positive 283.68, make that negative. Now we can eliminate, right? Our juices will eliminate. If I add straight down, I get negative 20W equals 2. Let's see if I can combine these together. 278 plus negative 283.68 is 4.8, sorry, negative. Divide by negative 20 on both sides. And we end up getting 0.24. Okay, this means that water costs 24 cents. Let's plug back in to find out how much the juice costs. I will again use my original equation. So 18J plus 32W equals to $19.92. 18J plus 32. I know how much water costs now. It costs 24 cents. equals to $19.92. 32 times 0.24. I have 18J plus $7.68 is equal to $19.92. Let's subtract $19.92, subtract $7.68. So minus 768 on both sides. I end up getting 18 juices is equal to $12.24. And then to find out how much each juice costs, you're going to divide by 18. And you get your juice is 0.68. So let's write our answer. Let me back up so we can see all the work. Juice costs $0.68. Water costs $0.24. And that is our final answer. Thank you for watching our recap video. I hope it helps. If you have any questions, of course, bring them to class. Otherwise, again, thank you. I really appreciate you taking your time to make sure you're doing better in our class. Bye.